I have taken certain scenario or the examples for which we can go for correlation analysis. So in what cases we can generally adopt the correlation analysis. So HR manager would like to know if an increase in a pay would result in a lower absenteeism. So HR manager want to know the relationship between the salary and the absenteeism, or the pay and in the absenteeism. A marketing manager would like to know if hike in price has something to do with decrease in product sale. So price and the product sale. Here the marketer manager want to know the relationship between the price and the product sale. A social science researcher would like to know if increase in age result in decrease of conflicts at home or work. So age and the conflict at home or work. So here the social science researcher want to measure or want to know association or want to know the relationship between these two variables. It is important to note that correlation does not provide any information about cause and effect. Through correlation, we cannot know the cause and effect relationship. Now, what is cause and effect relationship?
Sorry, ma'am. Again,
What is
please.
cause and effect relationship? Cause and effect relationship means if we change something in variable 1, then we can see the change in another variable. That is the cause and effect relationship. Okay. Now, correlation only measures the relationship or the association between two variables. It does not provide any information about the cause and effect relation. If we want to measure the impact, then we have a regression analysis. So to be very clear, please note down that correlation only measures the association or the relationship between the two variables. Understood? There are a
Yeah.
number of statistics available from SPSS depending on the level of measurements and the nature of your type of data. So again, there are two kinds of the correlation are there. One is the Pearson product movement correlation, and second one is the Spearman correlation. If your data or your measurement scale is an interval or a ratio, then you can use the Pearson product movement. And if you have ordinal data, then you can use the Spearman correlation. But again, as I yesterday told you, that in majority of the cases, we mostly use the parametric test. So like t-test, ANOVA test, or the Pearson product movement correlation. So we do not generally calculate the Spearman correlation. Now, what is this Pearson product movement correlation coefficient? The correlation is indicated by R. So an interval scale is 1 when there is an order and the difference between two values is meaningful. So this is what we have already seen yesterday. And however, in contrast to interval, ratio have an absolute zero that allow us to perform a huge range of descriptive statistics and inferential statistics. So yesterday we have seen the same examples, whereas the Spearman correlation that is indicated by the RHO procedures uses the ordinal scales, which ordinal scale means which has the order. For Pearson correlation, there are certain properties which we have to look into. So Pearson R is designed for interval or a ratio level or a continuous variable. It can also be useful if you have one continuous variable, for example, like employee commitment, and one dichotomous variable like type of organization, public or private. So if you have one continuous or one continuous variable and other was a dichotomous, then also you can use the Pearson correlation. The correlation is expressed in the form of a coefficient symbolized as a R. So Pearson correlation is generally indicated by R. A correlation of coefficient is normally reported as decimal number somewhere between +1 to -1. So again, the range for the correlation is also from -1 to +1. We have a positive, negative, or a zero correlation. The value of correlation coefficient lies between again -1 and +1. High absolute value of R indicates strong relationship between the two variables. Low So if we get the value which are again the positive, then we can say that there is a strong relationship between those two variables. Positive value of R indicates positive correlation. So as value of X increases, the value of Y also increases. The negative value of R indicates negative correlation. And if we get the zero value, which indicates that there is no relationship between the two variables. So we have a positive, negative, and the zero. Positive correlation means when positive one variable is increasing, the value of another variable is also increasing. Negative, the value of one variable decreases, the value of another variable was also decreasing. And when there is no relationship, then there is no line or no slope you can see here. So here are the ranges of the interpretation. How can you interpret the correlation coefficient? So this is the values. The plus one means perfect positive. If you get the minus one, then it is a perfect negative correlation. If you get value of plus 9, then it is very high positive. If you get minus 9, then it is a minus 9 to plus 99, then it is a very high positive, or it is, if it is a minus, then it is a negative. Plus or minus 0.70 to plus or minus 0.90, high positive or negative. High positive, high negative. Then between 5 to 7, you can say the moderate relationship. If it is between 0.3 to 0.5, then low, positive or negative. If the value is between 1 to 3, you can say very low, positive or negative. And if it is a point plus or minus 0.0 to 0.1, then it is marked low and negligible positive or negative correlation, you can say. So again, the same, if the values range in higher side, upper side plus 1 or minus 1, you can say there is a positive or negative relationship. But if it is a false in a zero number or zero value, then you can say there is a no relationship between those variables. Yes. In a correlation, there is one more spurious correlation. Now, what is this spurious correlation? So, one of the major problem with correlation is the possibility of spurious correlation between two random variable, which in many cases is caused due to some other latent variable. Latent variable means something hidden variable that influence both variables for which the correlation is calculated. Now the crime rate versus the ice cream sale. It has been reported that the sale of ice cream and crime rate are positively correlated during summer vacation. We have taken one example, or it has been reported that sale of ice cream and crime rates are positively correlated. Now, when the researcher have run the ice cream sale and the crime rates, they have found that these both variable are in a relationship. But do you think that sale of ice cream and crime rate are related or not? What do you think?
Not related.
Not related?
Apparently, it seems that it should not happen.
Yes, it is, because both the variable are a different variable. But what is spurious correlation? Here you can see that because of some other latent variable or a hidden variable that influence both variable for which the correlation is calculated. Now, when we run for certain kind of the variable, then we have found that because of some other variable, the relationship is exist between these two variable, like the sale of ice cream and the crime. Why? What do you think? What is the reason for that?
Maybe spurious correlation is much better for the use of law enforcement agency, something like that, CID or something.
Okay, so I have already written the answers. The ice cream is not driving the crime rate. In the case, the hidden variable is the temperature, because in a summer, what happened? This in summer the temperature is high, so that's why in summer the most of the people used to eat the ice cream. Why? In summer, there is an increase in crime rate because people on vacation and locked houses become easy target. So here, what is our hidden variable? The temperature or the summer vacation is the hidden variable. So because of this hidden variable, when we run the test, we found the relationship between the sale of ice cream and the crime rate. Understood? So whenever we run certain kind, we found the relationship, but actually in the case there may be no relationship between those two variables, or maybe the relationship exists because of this spurious correlation or because of the hidden element. Understood, everyone?
Yes, ma'am.
Yes, ma'am. Yes, ma'am. It is very
Okay.
excellent.
Yes, okay. So to understand the correlation, how can we calculate the correlation in SPSS? I have taken the two example. In one example, I am checking the day's temperature and the number of patrons at the swimming pool. Now I want to find out the relationship between the day's temperature and the number of persons coming at the swimming pool. Now I want to check the relationship. What do you think? Is there any relationship between these variables?
Madam, would you please repeat?
I want to check the relationship between the day's temperature and the number of patrons at the swimming pool, number of people coming to swimming pool. I want to check the relationship between these.
Yes, madam.
Heat increases, people, the chance of coming to swimming pool will be
Yes, so
more.
it is a basic phenomena. If the temperature rises,
It's
the
a
number of
high and
people coming to swimming
the
pool,
swimming pool is
definitely.
high.
So there is a
There is a-
relationship. But how
there is
can
a
I
po-
say? I cannot say in a research. I cannot say like that. No, for that I have to prove. Hello, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. So the first example which I am taking is I am checking the relationship between the day's temperature and the number of patrons at swimming pool. So this is my two variable. One is the temperature. How can we measure the temperature? So temperature is again measured in a number. The patron as well, we can measure in a number. So the data view, this is the temperature, and the patrons. Patrons means the people who are coming at swimming pool. Now I want to check the relationship between the temperature and the